the square, the first thing you want to do when you're trying to solve by completing the square is you need to decide whether is this a perfect square trinomial or not. How do you know? You take the b value, which is 4, cut it in half, and square it. Is that value equal to -9? No. So that means this is not a perfect square trinomial. So what we want to do then is get rid of that 9. Go ahead and add 9 to both sides so that it cancels there. Rewrite the problem. Leave a little space. And what we want is we want to put the value we need to make this a perfect square trinomial here. Half of 4 is 2. 2 squared is still 4. So we need a plus 4 right there. But we have to, remember, just like before, we have to do the same thing to both sides to keep balance. So this, since it's a perfect square trinomial, we can rewrite it as x, half of that, plus 2, squared, will be equal to 13. So when we take the square root of both sides of the equation, the square root will cancel the square. Those will cancel each other off. You'll have x plus 2 equal to plus or minus square root 13. Now, when you have square root stuff, you take the square root of both sides, you need to make sure you put plus or minus on that square root because we have to consider both the negative and the positive roots. 13 is not a perfect square, nor does it have any factors that are perfect squares. So we're going to leave it like it is, subtract 2 from both sides, and our answer, if we were asked to leave it exact, would be -2 plus or minus root 13. That represents 2 different answers. If they want you to find the decimal form, and they want you to round it to the nearest 10th, let's say, then in your calculator you put -2 plus square root 13, and you get 1.6, and then you start over and you put -2 minus square root of 13, and you get -5.6. So that's another way to write the same answer. Is -3. Squared is 9. Add 2, add 2. We need a plus 9.
I got you.
So that should be x minus 3. Then you take the square root of both sides.
I'm just confused on
So when you take the square root of both sides, you end up with x minus 3 equals plus or minus square root of 11. You'll add 3 to both sides to get x by itself. That is your exact answer. And then you can put 3 plus square root of 11 and then 3 minus square root of 11 to get your 2 decimal answers. 6.3 or negative 0.3 if we rounded to the nearest tenths place. This left side is already a perfect square trinomial. And I hope you can tell when it is and when it isn't. Take B, cut it in half, square it. If that's the same thing as C, it's a perfect square trinomial. So you take half of that, and that's what goes inside your parentheses. Plus 3 squared equals 25. So we didn't have to make any adjustments. It was already a perfect square. And now we take the square root of both sides. But this time, it turns out nicer. Get x plus 3 equal to plus or minus 5. So our answer, when we subtract 3 from both sides,
X plus or equals plus or minus.
and then you can write both answers, and both of them are accurate. Should get 2, or x should be negative 8. All right, somewhere on your test, you need to write the quadratic formula. X equals negative b plus or minus square root. The discriminant I'm going to write in red. It asks just for the discriminant. So all you want to find is the value that would be underneath the radical. All they ask for is the b squared minus 4ac value. Because whatever's under that radical will kind of tell us what kind of roots it's going to have, if any. So we get over here and say, okay, a is 9. B is negative 12, C is 4, and we start plugging it in just to the b squared minus 4ac formula. Negative 12 squared minus 4 times 9 times 4. What we get? So when it's equal to 0, what does that tell us about the roots for this parabola? 1. One real root. Because when we do plus or minus 0, it's not going to give us 2 answers. Add 0, subtract 0, there's no difference. So we're not going to get 2 different values this time. Okay, so let's just make a list. Okay, for the discriminant. If it's equal to 0, then that means you have 1 real root. If it's negative, it means there's no real roots. If it's a perfect square, if this number that we come out with is like 9 or 16 or 25, something nice square root, then we're going to have 2 rational roots. Okay? 2 rational roots. It's going to come out nice. Rational is automatically real, so we don't need to say it's 2 real roots. If we say it's rational, that automatically means it's real. If it's not a perfect square, then there's 2 irrational roots. And in that case, you'll probably have to round if they ask you for the decimal. Or if they ask you for the exact, you'd have to leave it as a radical. So, back to this problem. Oh, we already decided that it's going to have 1 real root. The discriminant is 0. It's going to have 1 real root. Then, b squared minus, I'm not recording, b squared minus 4ac. And what do you get? $33. This comes out to 33. B squared minus 4ac. 81. 9 times 9 is 81. Minus 4 times A times C. 2, 3. 12 times 4 is 48. 81 minus 48. 33. So that means we have 2. This is not a perfect square. It's positive. So it's going to be a real root. But it's not a perfect square, so it's going to be an irrational root. 2 irrational roots.
When's that meeting? -81.
Number 12, now you're going to find not just the discriminant, you're going to find the solution, the exact solutions, using the entire quadratic formula. Okay? All we did before was just found how many zeros they were, but we didn't know what they were. We didn't go that far. Here, we want to find the zeros. Use the entire quadratic formula. Get it into standard form first. Identify A, B, and C, and then plug them in to the quadratic formula. So when you plug it in the quadratic formula, negative b plus or minus square root b squared minus 4ac all over 2a. We can't simplify any of the numbers. The only thing we can do is we're not allowed to, technically, we're not allowed to leave our answer with a negative underneath the radical. So, we bring it out as an I. That is all you can do. Okay, 13 is already in vertex form. So it's going to be easy to find the vertex. Caleb, what's the H value? Yes, you do. Where is the H value? The 5. Of course, what do we have to do with that?
You have to.
Make it negative. So the h would be negative 5. And k, Sandra, what's k? Negative 7. So our vertex is negative 5, negative 7. Our axis of symmetry, Jackie, what's our axis of symmetry going to be? Why? Well, then you turn your desk. Now, writing a problem or changing it from standard form to vertex form is going to look a little bit like completing the square or solving using completing the square, and you are completing the square, but you're not solving, and so you do something a little bit different. We don't have, see, on those previous problems, we didn't have a y value. If you look back at problem number 7 and 8, when we were solving using completing the square, there was not a y variable. There is in this case. So y being by itself is kind of like setting it equal to 0. But what we want to do here is we're only gonna work with the right side. We're not going to put something else on the left. And here's what we're going to do here if we're going to put it in vertex form. X squared minus 6x, we're just going to move the 8 over to leave room to complete the square. Now the value we need here is we're going to go about finding that value the same way we did on 7 and 8. We take half of b and square it. What is that? 9. So we need a 9 right here. But since we're on the same side of the equal sign, we don't add 9, add 9. We add 9, subtract 9. Because we're on the same side of the equal sign. So these first 3 terms is our perfect squared trinomial, and it factors into x minus 3 squared. This becomes negative 1. And that's in vertex form.